Now that we have a representation of types that includes type variables, let's look at examples of unify, working our way towards implementing unify. I'm going to simplify slightly by only considering the type arguments to unify, not the third argument that is an expression for reporting errors. That'll be good enough for looking at what unify should do. You'll have to do a little bit more work to turn these into actual tests. The unify function is meant to compare two types and make sure they're okay and install type equivalences into type variables as appropriate. So if we ask unify to compare the num type to the num type, it should be happy, and it reports success by returning 0 values, a 0-sized tuple here. And similarly, comparing bool t to bool t also is success, returning 0 values. It's okay to return 0 values because if we want to fail, like when unify is asked to compare num t and bool t, then it doesn't return any values, but it doesn't return at all. It'll raise the exception, no type. So when we want to check for failure, we're writing tests that raise exceptions. Success is tests that return no values. The interesting cases of unify are going to be where there's a variable, a type variable argument. In this case, we have a type variable and no type has so far been assigned to the variable, right? It still has none in its box. So in this case, unify should be happy. It should be able to unify numt with this variable by assigning numt as the variables to the variable type. We don't see that assignment in this test case, but we'll see it in somewhere in a little bit. For now, we just have this success in the case that the equivalence can be set up. If the variable already has been assigned some type, here we assuming it's been assigned to the type numt, then unify will have to compare that to the type that is given as a second argument. In this case, numt matches up with numt, so it succeeds with 0 results. But if we had previously assigned bool t to be the type for var t, now this bool t is not consistent with numt, and unify is going to complain. To expose the assignments that unify does, let's write a larger test like this. Let's let t be this type variable that starts out without an assignment. And then when we unify that type variable with numt, as we've seen, it will succeed and return 0 values. But now when we try unifying that same type variable with bool t, at this point t will have inside of it the numt will have a sum of numt will replace the none right here, and so unify will see numt versus bool t and it will fail. So this example illustrates the side effect that unify has in installing an equivalence, installing a type into the type variable t. And notice that we had to let t be this particular var t. If I wrote var t box none twice, that would be a completely different example. The side effects here are exposing the identity of this variable, and specifically the identity of the box that it contains. Here's an example where it succeeds because this first unify sets t to numt, and then we check again against numt, and so that succeeds. Here's a case involving arrows. So I start out with an unassigned type variable. I unify not just the type variable, but the type variable as the argument position in an arrow. And unify will see two arrow types, and so it will compare the argument and result type separately. Clearly, the result types will succeed, and the argument types will also succeed here with the side effect that t is unified with numt, and so gets assigned numt. That means the second unify will also succeed because t is numt. On the other hand, if I take this same type variable, put it in the argument position, and try to unify it with itself, this one should fail because of the occurs check, right? Because the type variable is the second argument here, but they'll just get swapped around. That type variable appears within this other type variable, and so the type checker should fail at the occurs check. On the other hand, if I have two type variables that are unconstrained and I unify them to each other, that should be fine. One or the other of these type variables will get assigned to the first one. So maybe t2 is set to be the same as t1 or vice versa. It won't be both ways. It'll only be one way or the other. And then those effectively unifications through those two separate type variables can communicate. So here we set t1 to t2. And then we also set t1 to numt. So that would have the effect of setting t2 to numt if we set t1 to t2. In any case, maybe it goes the other way, but by the time we try to compare t2 to bool t, it will already be unified to t1 and numt both, and so this will fail. It doesn't matter whether we do the checks in the reverse order. Here I'm setting t1 to t2, setting t2 to bool, and then comparing t1 to num. Again, this should fail because t1 and t2 have to be the same. And finally, looking at some arrow cases here, I've set t1 to be equal to t2 arrow bool. So far so good. But then when I also say that t1 should be numt arrow t2, then we have a problem, because this will cause t2 to be set to numt, but then the bool t comparison to t2 will fail because t2 will have been set to numt.